Alright, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to Basic Physics Experiment from Physics Department in Gajah Mada University, and in this occasion we will talk about Laplace constant experiments. The goals for this experiment are first to comprehend the meaning of Laplace constant, to demonstrate of adiabatic process, and to determine gamma or the Laplace constant itself is the ratio of Cp or specific heat in constant pressure and Cv is specific heat in constant volume. An adiabatic process is a thermodynamics process that occurs without transferring heat between thermodynamic system and its environment. Consider the observed gas is an ideal gas. The ideal gas itself is shown by this expression, and I think you have learned this in high school or something. So the pressure times the volume is equals to N times the R constant times the temperature. And the process itself is an adiabatic expansion in constant volume. So remember this. The process itself is an adiabatic expansion in constant volume. Laplace constant can be measured with the ratio of pressure between before and after the expansion, or as shown in equation number 1. So gamma or the Laplace constants are equals to the ratio between the pressure before the expansion and the pressure after the expansion. So the apparatus that we have in these experiments are first the large glass vessel containing the observed gas, the rubber tube to blow the gas, the T-shaped pipe to close and open the vessel, the manometer to measure the gas pressure in large vessel, and the liquid. In this experiment we use gasoline that fill in manometer. The set of the apparatus as is shown in figure number 1, and on screen is kind of look like this. The method for these experiments are first, fill the vessel with observed gas or human breath. So yeah, you blow these things. The liquid in the right pipe of the manometer will rise. When the difference between right and left pipe is around 30 cm, close the pipe and wait for the liquid to become steady. The difference height is noted as H1. When it reaches thermal equilibrium, or we estimate it between the gas and the vessel on the surrounding environment, let the gas from the vessel flow through the manometer for 1 second and then close. It makes the gas in the vessel experience adiabatic expansion. And note that the duration of gas that flow through the manometer really determine the result. So I think you can underline this sentence by itself. When the adiabatic expansion occurs, the surface of the right pipe of the manometer will decrease. It means that the pressure of gas in the vessel decreases too. Wait until it becomes steady, and the different height is noted as H2. Repeat the same procedure until we get 5 data for each H1 and H2.
Selamat siang teman-teman semua. Pada kesempatan kali ini kita akan melakukan praktikum dengan judul pengukuran tetapan Laplace. Adapun tujuan dari praktikum ini yaitu memahami arti dari tetapan Laplace, memperagakan proses adiabatis, serta mengetahui dan mengukur tetapan Laplace dari praktikum ini. Selanjutnya, adapun alat dan bahan pada praktikum kali ini ada manometer beserta skala, minyak, bejana, selang, dan terakhir keran dengan saluran berbentuk T. Oke, langsung kita mulai pengambilan datanya. Yang pertama kita atur kerannya sehingga yang terbuka hanya saluran ini dan ini saja, sehingga yang ke bejana tertutup. Oke, selanjutnya kita tiup sehingga nanti terjadi perbedaan ketinggian antara pipa manometer kiri dan kanan selisih sebesar 30 cm. Oke, kita tiup. Oke, ini kurang lebih plus minus terjadi selisih 30 cm. Kemudian ini kita catat perbedaan ketinggiannya antara pipa kiri dan pipa kanan sebagai H1. Selanjutnya kita buka antara saluran ini dan saluran ini sehingga dan ini tertutup. Gasnya akan berekspansi Dan kemudian setelah sudah stabil, ada perbedaan ketinggian lagi, kita catat perbedaan ketinggian antara pipa kiri dan pipa kanan sebagai H2. Itu adalah ketinggian setelah gas berekspansi. Kemudian kita kembalikan lagi sehingga sama, dan langkah tersebut diulangi hingga terdapat 5 data. Oke, tadi kita sudah melakukan pengambilan data. Jangan lupa, H1 adalah perbedaan ketinggian sebelum gas berekspansi, dan H2 adalah perbedaan ketinggian setelah gas berekspansi. Oke. Sekian untuk praktikum pada kali ini untuk pengukuran tetapan Laplace. Selamat mengerjakan laporan.
So in this section, we will talk about the analysis that we use to get the value of the Laplace constant that we need. So first thing first that you should know is the initial gas pressure, or P1, are shown by the equation number 2. It's kind of like this. So rho is liquid density that fills the manometer, G is Earth gravity acceleration, and P0 is the air pressure of the surrounding environment. So initial gas pressure, or P1, are equals to rho times G times H1, or the difference in height before the expansion, plus P0. After the expansion, the gas pressure in the vessel becomes equation number 3. P2 are equals to rho times G times H2, the difference in height after the expansion, plus P0. Gas pressure are equal to height's difference between right and left pipe of manometer. Hence, we can rewrite equation number 1 to equation number 4. So, the Laplace constant, or gamma, are equals to the ratio between H1 and the difference between H1 and H2. Then, we will use this equation to get 5 data of Laplace constant. And then you can find the average of the gamma or the Laplace constant. Yeah, so you just sum these things and divide it by 5. And for the error of the gamma or the Laplace constant, you can use this equation number 6, or the expansion of the equation number 6 as shown in these equations. So this is the data that you will use to measure the Laplace constant. We have 5 data of H1 and 5 data of H2. Remember, this height difference is shown in centimeter. So yeah, thank you for your attention and good luck for your assignment, guys.